Somewhere beyond the orbit of Mars, right now, there is a piece of ice and rock no more than a few kilometers across, moving away from us at nearly 60 kilometers every second. It will never come back. It did not form here. It did not form anywhere near here. And when astronomers finally measured what it was made of, the answer was strange enough to take a paper in Nature to explain. This comet is roughly 12 billion years old. Our sun is 4.5, which means this object was already ancient, already drifting alone between the stars, for something like 7 billion years before the sun switched on, before the Earth existed, before there was anything here at all. And the star that made it has almost certainly been dead for a very long time. This is the story of the oldest thing humanity has ever gotten close to. Start with how rare this is. Every comet you have ever heard of belongs to the sun. Halley, Hale-Bopp, Neowise. They are on leashes. They swing out. They come back, sometimes over thousands of years, but they are bound to our star. And they were born here, out of the same cloud of gas and dust that built the planets. An interstellar object is different. It is not bound to anything. It fell in from the dark between the stars, and it is moving too fast for the sun to hold on to it. It passes through once, bends slightly, and leaves forever. We have only ever found 3. The first was Oumuamua in 2017, a strange elongated thing that was gone before anyone could get a proper look at it. The second was Borisov in 2019, which behaved much more like an ordinary comet. And the third was picked up on the 1st of July, 2025, by a survey telescope in Chile called Atlas. That is where the name comes from. 3I Atlas. The 3 means third. The I means interstellar. 3 objects. In the whole of human history. Now here is the problem that makes this story interesting. How do you work out the age of a rock you are never going to touch? On Earth, you date a rock using its radioactivity. You measure how far certain unstable atoms have decayed into other atoms. You know the rate they decay at, and you count backwards. It is a clock built into the stone. But that needs a sample sitting in a laboratory, and nobody is landing on this thing. It is moving far too fast, and by the time anyone found it, it was already on its way in. So astronomers did something cleverer. They did not try to date the comet. They read where it was born. Water is 2 hydrogen atoms joined to 1 oxygen atom. But not every hydrogen atom is identical. Most of them are a single proton. A small fraction carry a proton and a neutron, and that heavier version has its own name. Deuterium. Water built with deuterium is called heavy water, and it is very slightly heavier than the ordinary kind. Here is the useful part. The ratio of deuterium to normal hydrogen in a piece of ice is not random. It depends on how cold it was, and what was around at the moment that ice first froze. Colder conditions lock in more deuterium, so the ratio works like a fingerprint of the time and the place the ice formed, and once it is frozen in, it stays there. Every comet in our solar system carries more or less the same fingerprint, because they all froze out of the same cloud, at the same time, around the same young sun. When the telescopes measured this one, the fingerprint was wrong. It carried about 30 times more deuterium than any comet born here. 30 times is not a rounding error. It is not a slightly unusual comet. That ratio points to ice that froze somewhere far colder and far older than anything in our neighborhood. The team, led by a NASA astrochemist named Martin Cordner, worked through what kind of environment produces a signature like that. The answer was the early Milky Way, a galaxy still assembling itself, poor in the heavy elements that later generations of stars would go on to manufacture. Cold, in a way our own solar nursery never was. Their estimate came back between 10 and 12 billion years. The Milky Way itself is around 13.5 billion years old. So this comet formed while our galaxy was still young. Not young by a few million years. Young enough that the sun, the Earth, and every atom in your body were still 5 to 7 billion years in the future, waiting to be built out of material that had not been forged yet, and it did not form on its own. Comets are leftovers. They are the debris of planet building, the material that never quite made it into a world. So somewhere out there, 12 billion years ago, there was a star with a disk of gas and ice wrapped around it, and this object was part of that disk. Then something threw it out, a passing star, a migrating giant planet, a gravitational shove of some kind, and it was thrown out into interstellar space. Now think about what has happened to its home since. Stars that formed that early in the history of the galaxy are mostly gone. The bright ones burned through their fuel billions of years ago. If its parent was a massive star, it died in a supernova long before the Earth had finished cooling. Even a modest, patient star has had 10 billion years to run itself down. So the object drifting past Mars is a piece of a solar system that almost certainly does not exist anymore. The star is gone. Whatever planets it had are gone, or frozen in dark. And the only surviving witness is a lump of ancient ice that happened to fall through our neighborhood, once, at a moment when there was somebody here with a telescope pointed the right way. That is why astronomers dropped everything for this. We have never had a sample of the early galaxy. Everything we can study, every rock, every comet, every atom on this planet, formed here, from one cloud, at one time. It is a single data point. We have been trying to understand how planetary systems form across the entire universe from a sample size of 1. This is a second data point, a piece of a different system, built under different conditions, at a different moment in the history of the galaxy. And it walked straight into our instruments. What it tells us is quietly encouraging. Water ice, carbon dioxide, organic molecules, the same basic chemistry that built our solar system, present 12 billion years ago, in a completely different place, around a completely different star. The ingredients were there almost from the beginning. Now, you have probably seen the other version of this story, because every time an interstellar object turns up, the same claim follows it, that it is a probe, that the trajectory is too precise, that somebody is hiding something. A Harvard astronomer named Avi Loeb has spent years arguing that visitors like this deserve to be taken seriously as possible technology. And to be fair to him, asking the question is not unreasonable. Checking is what science is for. But you have to follow the evidence, and here the evidence is not subtle. This object grew a coma, it grew a tail, it vented gas and dust, it brightened as it fell toward the sun and faded as it climbed away, and its chemistry reads as ice, carbon dioxide, and dust. Those are the behaviors of a comet, and they are extremely difficult to fake. The real story does not need the alien. A 12-billion-year-old fragment of a dead star system, older than the sun, drifting into range for a few months, and then leaving forever, is stranger and better than anything invented for a thumbnail. And it is going now. It passed closest to the sun at the end of October 2025, cutting just inside the orbit of Mars. And it has been climbing away from us ever since, getting fainter every week. Soon it will be beyond the reach of even our best telescopes. After that, it will spend the next several billion years crossing the dark, toward whatever comes next. We got a few months with it. That is all we were ever going to get. But the next one is already out there. Somewhere in the dark between the stars, other fragments are falling toward us, from other systems, from other epochs. And with the new survey telescopes coming online now, astronomers expect to start finding them not once a decade, but several times a year. Which means the question is no longer whether we will meet another piece of a dead star system. It is whether, next time, we will be ready to go out and catch one. If you want to be here when that happens, subscribe, because we will be following every one of these visitors as they arrive.